Welcome to the Mechanism Sessional Group Project. Now, now I'll introduce my team members, Nikhil Reddy Murray, Maulad Vivek Naik, and myself, Teja Tishu. Now we have taken the truck problem for the simulation. We'll be solving this. We'll be showing the simulation in the SolidWorks followers. Now I'll explain the synthesis of mechanism. As this truck problem is a four-bar mechanism, I'm going I'm going to explain the angles. We have drawn the kinematic diagram of the given truck. Here in this diagram, alpha is the bin tilt angle, beta is the angle of opening, theta 4 is the 90 minus alpha, and theta 2 is 90 minus beta. We can relate alpha and beta, that is theta 2, theta 4, and proceed further synthesis for mechanism. Initial conditions, as bin is horizontal position and door closed, we can see that theta 4 and theta 2 are right angle to each other. To synthesis the lengths, we can use Fredenston equation k1 cos theta 4, k2 cos theta 4, k3 cos theta 2 minus theta 4. Here we can see that k1, k2, k3 are the constants. K1 is equal to L1 by L2, K2 is equal to minus of L1 by L4, K3 is equal to L1 square plus L2 square plus L4 square minus L3 square by 2 L2 L4. We need three sets of theta 4 and theta 2 to find all the lengths. We have one set, the initial conditions. Theta 4 and theta 2 are right angles. Generally, the maximum bin tilt angle is around 60 degrees. And let us assume the maximum opening angle is 80 degrees for the bin tilt angle. Theta 4 is equals to 40 degrees. 90 minus 40 is 60 degrees. And theta 2 is equals to 80 degrees. That is 90 minus 10. To further proceed, we just start with an assumption that theta 4 and theta 2 are linearly related, even though we know that they are not varying linearly from Fredholm equation. So the third set of angles will be 50 degrees and 65 degrees. Generally, the height of the bin around 5 meters. So we'll fix L1 as 5 meters and we'll find the other lengths. Now here from the Fredholm equation, we have arrived at these lengths and constructed the mechanism in SolidWorks to check whether it really works practically. So now we'll see the SolidWorks mechanism. These are the lengths and the mechanism which was done in the SolidWorks, and this is the initial stage of the dumper bin, and we move that to check the dead center configuration of it. So that, yeah, this is the dead center configuration. Here, the bin angle is the built-in tilt angle is 103.44 minus 90 degrees is 13.44 degrees, which is very less. The bin can't move beyond the 13.44 degrees. This is practically very less, and we cannot use that for our purposes practically. So we should think of other cases. And here also the the door opening angle is 33.05 degrees, which is also less. So hence this mechanism won't sustain practically. So we have to go for case two, where we take the maximum opening angle as 60 degrees and check whether it. This is a case two, and these are the lengths which we want. The case two, considering the case two in Fredholm equation. This is the initial stage, and these are the dead center configuration, from which we get the tilt angle as 111.33 minus 90 degrees, which is 21.33 degrees, which is also less. And the door opening angle is 31.46, which can also be considered as less. There is no much change
while we change the opening angle from a opening angle in the case. So we should think of other ways. For the case 3, we'll consider all links to be of equal length because of the reason that generally, if the difference in lengths of the opposite links is smaller, we get a greater delta angle, like a parallelogram we can consider. So in this case, we consider the difference in length as zero. This mechanism has a complete rotation, which can result in a higher tilt angle, of course. But can we consider this as a final mechanism? No, because the problem here is always the door will remain vertical, which results in a smaller opening angle. So to avoid this, we have to make some other changes in the link's lengths. This is our next case where we considered a slight change in the one of the length, one of the link lengths, which is from 5 to 4.5, which makes the a length difference as in the opposite links as zero point 0.5, which is also less. And then this is the decenter configuration of the mechanism, which is resulting in a pretty good angles, greater angles because the opening angle here is 71.81, which is pretty good, but this can still be more. So we'll consider the cases. Again, this is a change in the link lengths through which we got another case. It's here the difference in opposite link lengths is one is 0.02, which is very less, and zero point 0.5, which is also less. Here are the dead center configurations. There is a slight increase in opening angle from the previous case, which is to 76.99 degrees. This can still be increased. So we consider another case, which gets to our final model dimensions. This is the final case. The links and link lengths are considered to be 5, 1.72, and 5. This mechanism has a maximum tilt angle as 56.27 degrees and an opening angle of 80.51 degrees, which are greater than what we have seen in the previous cases. So this can be considered as a final uh, model for the truck adapter. These are the final results. And now my friend Vivek will continue with the simulation.
So here is our solid mechanism. So as we move the bin, this mechanism works. So we will see here. So in the final position or the maximum position, the the maximum bin tilt angle is 56.27 degrees, whereas the maximum opening angle is 80.51 degrees. So here in the extreme position, the first difficulty we have faced is here these links get straightened, and it is the center or dead center position of this mechanism where it gets stuck and cannot be moved further. So we have fixed the angles so that the mechanism runs smoothly like this, as you can see here. So we have fixed that problem of the dead center by fixing the angles. And the second main problem we have faced is, so as we move the mechanism, this door of the mechanism goes smoothly till certain angle, that is 50 degrees in this case. And after this 50 degrees angle, it starts rapidly going,
which in practical case we don't know. So to fix that, we have adjusted with some angles and mechanisms. So we have adjusted it so that it does not exceeds the angle where the rapid movement of the door starts. So we can see that phenomenon in this graph also. So here you can see the blue line is the theta 2 line, and the orange is theta 4 line. So here you can see the theta 2 line is very smooth and linear, but the theta 4 line is smooth till certain angle, and after that it is rapid. So that certain angle is 50 degrees. So we have found out this, and what we have done is we fixed the mechanism such that it does not exceed that angle, so that the door opening is smooth. And in the practical situation, we don't want so that we restrict the rapid movement. So we have done that. So the third problem we have faced is in the rest position or the horizontal position, we don't need any lock to the door. Whereas to start the initial movement of the bin, it is somewhat difficult because you can see the door of the opening or this mechanism is entirely dependent on the weight of this bin. So what we have done is we have adjusted somewhat. We have adjusted slot here, as you can see. We have adjusted slot so that the movement of the bin is very smooth and it is uh, attained to the needs of the practical situation. So we have fixed the problems of the this mechanism, and we have finally arrived to the this mechanism, which is practically perfect to use. You can see this is our mechanism. Thank you.